Good morning, and thank you for joining our crash course on AI-ready data platforms for manufacturing. Bit over a year ago, we had a crash course about building effective data platforms, and here we are building on top of that foundation. The difference here is that we are focusing on the manufacturing nuances, so we are covering AI usage on manufacturing operations and enterprise functions. Why we are talking about this now is we are seeing customers experimenting with AI, piloting AI, and being stuck in the POC phase with their pilots. Where we are heading with these pilots is towards AI-ready data platform. So we are covering how to go from the siloed data into scalable intelligence, and how the leading manufacturers are building data platforms that makes AI an asset. Before we dive deep into the subject of today, we are going to introduce who we are and what Solita is. So Ville, please.
Thanks, Kalle. And Solita might be already familiar to many of you. Still to mention, we have been able to maintain the profitable growth also during a little bit non-optimal market times. So Solita has been going strong all of these years. And what Solita then actually does, in a nutshell, we create value from data in a connected world. So on the right side of this slide, you will see those 6 different bullet points. So no matter if we're talking about data, connectivity, strategy, cloud, development, whatever it might be, Solita knows how to combine these to sustainable, efficient data solutions. Before we go to the actual content, let's introduce us as the hosts of this crash course, and let's start with Kalle. So Kalle Myllymaa has roughly 20 years of experience on the crossroads of IT and OT, the information technology and operational technology, what this crash course is all about. Kalle has been working on very versatile assignments, from pre-sales, assessments, investigations, to also very hands-on technical work. So at least I would call Kalle a real full stacker. That would be a suitable term for him. And Kalle is currently focusing heavily on applying AI and opportunities for the industrial processes. Kalle is originally from Tampere, but he has transitioned to Turku area for some reason, because this is not normally something that somebody should do. That's Kalle.
Thanks. Then a couple of words about Ville, our other host today. So Ville joined Solita 3 years ago to build OT IT solutions. Ville has been working in various roles in our customer assignments, from project administration to architecture and design. Ville sees that there's still a lot to do with combining OT IT, in particular what comes to multi-site manufacturing corporations. On the other hand, Ville moved from Turku area to Tampere area, so I don't know if that is something that I would recommend either.
Okay, fair point.
What we are going to talk about in our today's session is bridging the gap between AI ambition and manufacturing reality. So we will begin with the opportunities in AI for manufacturing, then discuss about why many factories are still lacking AI-ready data. From here, we will go into the architectures, how the data platforms have evolved, and what would be a practical blueprint for AI readiness. Then, to make it tangible, we are going to talk about a few customer cases. We will be concentrating on how to build practical AI-ready data platforms in real world.
Yes. And out of these sections, first we are going to briefly go to the manufacturing AI promise. So visioning a little bit, what would there be if we don't have any restrictions but only use our imagination, what the AI promise could be for the manufacturing companies. It can mean a lot of things. So it can be, for example, a report of choice. So you can just ask whatever you wish. It can be about instant regulation fulfillment. So whatever it might be, fetching the necessary information ad hoc, right on time. It can be the OEE comparisons, the overall efficiency, very important one for the manufacturing companies. A fleet overview, measurement of choice from no matter which site or location, supply chain management related topics, anomalies, history, alarm listings, availabilities, maintenance needs, after-sales opportunities. So there are plenty of options, whatever bottlenecks it might be. But then also, when going a little bit further, if we have covered all of these, there are still some little bit trickier questions left. So with very mature AI solutions, it could be possible also to answer to the questions, for example, where to invest next when we have all the data connected, everything available, and the good AI solutions in place. Advices on investments are also part of this promise. And then concerning manufacturing companies, of course, it does not need to be one way upwards from the process, but eventually also how to control the process systems, the SCADA or DCS systems, and so on. So it can go also quite tricky as questions. In manufacturing, of course, the location sites and the production process itself is in the core, but focusing on only manufacturing is not enough. So it needs also covering quite well the corporate functions around that. So if we're only utilizing or applying the AI to the manufacturing process, it still lacks the questions how to use it. But when we have sales and marketing related data and function covered, we are combining product engineering, research and development as part of the platform, production and supply chain, including the third parties, the vendors, suppliers, customers, maintenance and service related topics, and also finance function. Then we are ending to a very powerful system and powerful solution. Also, during this presentation, we are every now and then we are referring to our references, Solita public references on this domain, and we have selected Outokumpu and Ponsse as the examples here. So Outokumpu as the high-end steel manufacturer company, particularly for the sustainable steel, and Ponsse producing very high quality and advanced harvesting machines. And out of these corporate functions, of course, it's about combining all of these, but in this presentation, we are focusing with Outokumpu reference mostly on the production and supply function, and then Ponsse as an example for product engineering and R&D related data as part of the platform, and also how to include the maintenance and service business by utilizing this sort of AI-ready data platform.
AI does for sure sound promising for manufacturing. Do you see that there's any gap between the reality and promises?
Yes, I think that's a rhetoric question. So, of course, there is quite a big gap between this promise and then the reality, and that is just understandable due to a couple of reasons. So, the reality in most plants, mills, factories is still that whereas AI promises major impact, the development is quite often blocked. So it stops in the early phase, at least to the proof of concept mode. It might be due to several different reasons: lack of available machine data, lack of consistency in systems such as manufacturing execution system. Then we might have some data available like quality results, but there is no linkage between the other data that would reveal the root causes. Might also be that we have predictive models in place, but we don't know the different interrelations between the models and between the different assets related to that particular use case. Then it might also be that the AI pilots are kind of one-offs or skunkwork projects, so that they are not integrated as part of the platform and not therefore reusable. And then the data quality and trust issues are a big thing here. We are also going a little bit deeper on that particular topic later on. But then one important kind of reason for reality in most of the plants and most of the manufacturers is the legacy infrastructure. So industrial corporations are normally a result of quite long consolidation. So one company has been acquiring next one and next one and next one, and with each acquisition there has been some new systems, not very well harmonized systems as part of the system landscape. And this older infra and older systems, particularly on OT side, is normally designed and commissioned for local monitoring and control, but not to be connected to the as part of the common data platform or for AI use, which is of course a very fresh, very new thing. And this kind of architecture is not scalable, so even if we have some solutions for one plant, one location, it is not scalable along the whole company. So in these situations, normally everybody agrees on the need for harmonization, but it's very hard to justify the investment for this and justify the return on investment of system renewal. In our reference cases on Outokumpu side, before the data platform, data was scattered across the sites and systems and also causing slow analytics. And on Ponsse side, there was kind of division between the machine data and service data, and therefore limited visibility between these two. Then a little bit more on data quality. So data quality is a very important topic concerning the AI readiness, because the AI solutions won't work appropriately if the data quality is not high enough. And data quality we can break down to several different factors. So it can be sensor drift, so sometimes the measurements are not trustworthy because of the drifting along the time, if they are not calibrated accordingly. Then quite often there are missing values. So if we have downtime, we have the connection between the data sources and the platform down. There might be some gaps with the data, and we need to have some tools to interpolate or extrapolate or somehow add the missing data. Then there are sometimes inaccurate batch metadata, so we might receive the data batches, but it might be that the timestamp is wrong, or we don't know quite precisely what this data is about. So at some aspect the metadata is missing or distorted. Then manual logs and inconsistent naming is also part of the problem. So different shifts might use different naming conventions or different styles, and it gets hard to combine these as one solution. And eventually the uncontrolled process changes are also part of it. So if something changes, it might be that the information about this is not passed on, and it causes some distortion with the data. And what all of this leads to, so if the data quality is bad, KPIs become questionable, so we don't know anymore if we can trust on those. The root cause analysis becomes guesswork because we don't know the relations between the phenomenon that we are seeing and the underlying reasons for that. AI models fail, or they might produce noise so that it's not possible to see the essential and cut through the noise. And and also trust in analytics can just generally erode. So it doesn't make sense. It's not motivational if there is no good enough data behind, in a nutshell. Then a couple more words concerning the lack of context, because I think context is one of the most crucial phenomenons or features of this. So sometimes it might be the case that we have the needed measurement point available. So we know that here's the data, we have it, it's available, but it's not usable. And the reason for that is the missing context. And context can miss on several different reasons. So sometimes it might be the description. So we know the unifying ID for a measurement, but it's not human readable. There is no description, and we cannot tell what it is because we cannot read the mysterious code, and human being cannot therefore understand it. Then asset hierarchy and product data is one typical missing metadata, missing context. So we know that this is the measurement, but we don't know its place, what its place is as part of the big unified namespace, big asset hierarchy, company-wide asset hierarchy. So we don't know to which process line, to which device, which equipment it belongs to. Then some anomalies, we don't know how it looked like earlier, and we have not added the patterns, let's say healthy patterns or unhealthy patterns there, so we don't know when there would be the need for action. Then we don't know to which predictive models this particular measurement is participating, so we are not aware of the correlations between this measurement and some other measurements. Generally, it would be fair to say that contextualization is the link between one data point and the rest of the data. And this contextualization, therefore, it's necessary to get going with the contextualization. And it's not something that you just decide to build 100% now, but it's more like a wardening kind of activity, so that it needs to be done piece by piece consistently by adding the context along the way. Then next, some words concerning the OT-IT division. So historically, the operational technology and informational technology have divided to two very separate worlds. And there are a couple of reasons for that. So first, OT was built for control, not for analysis. So the main reason for the operational technology and automation is to run the mills, run the plants, and monitor what's happening in the mills. And these users are local with high real-time requirements, but it's not for combining it to any other data or doing deeper analysis. Then, on the other hand, IT was built for transactions and not for processes. So on this side, vice versa, it's about managing the business layer. It's if the number one addresses the question how manufacturing is done, the question two addresses why manufacturing is done, who needs these, who buys these, how the buying transactions are done, and all the related topics around that. But there has never been a middleman between these two worlds. So there has not been so far a very good technologies or platforms to connect these two worlds. And here we are we are explaining why the AI-ready data platform for manufacturing actually is the middleman between the OT and IT worlds. How should it go then? Should it be so that the OT world, automation world in the mills is expanding towards the IT from bottom down, or IT expanding towards the automation like from top down? And as mentioned, the two worlds are separate, but it's not only technology-wise. Technical aspect is only one aspect, but also the organizations are very, very separate. So there are not too many interconnections between the IT and OT worlds. location-wise as well. So quite often IT is centralized and then OT happens on each particular location, each particular mill. Latency-wise as well, so we are talking about different clocks. Then when we combine all of these and we try to combine these two worlds, let's first cover the bottom-up approach. So what if OT expands towards IT? So OT is mostly local, maintenance-related and hands-on technical domain. And from this perspective, we see that it's not very easy to proceed towards the IT and enterprise architecture. Whereas the top-down approach, meaning that IT expands downwards towards the operational technology, we see this as the way to go, because IT and enterprise architecture is anyways composed of multiple systems and very versatile data needs. That's why it's easier to expand from IT towards OT, incorporating OT as new data sources. We will soon also go this through in form of an illustration.
Yeah, so based on what you just said, I do think there's a gap between the reality and the promise. What we are proposing here is AI-ready data platform. How would you describe AI-ready data platform?
Yes, let's next go to that topic, and we will then first cover the AI-ready data platform characteristics. So now we're talking generally, it's not too much related to the manufacturing yet on this slide, but focusing on AI-ready data platform generally. And there are like 4 different features that I would like to emphasize here. And first one is the mechanisms and capabilities for ensuring the data quality. So we need to make it sure that the data quality is high, and therefore these mechanisms need to be built as part of the AI-ready data platform. Then the next one is efficient connectors and integrations. There might be there is already now very large amount of different data sources, data targets, and systems that need to be somehow integrated as part of the platform or connected to the platform. And there is, of course, yet more to come. So we need to make sure that we have very efficient, capable, versatile connectors for making this happen. And then the modularity is also important here. So as the data platform is expanding, we are talking about collaboration over different data workspaces. And these different workspaces and this modular structure needs to be able to work as one holistic system. The next aspect is kind of related to the modularity. So the catalog solutions have developed hugely just only in a couple of years, and it's not only about the visibility and findability of the data, but also data sharing and authentication for using the data on a controlled, secure manner. So when this happens, then we are able to also use the data without too big hesitation. In Outokumpu case, the data platform was aiming for factory co-pilots and AI solutions, so there was a clear target where to use it. And for Ponsse, the near real-time, event-driven and streaming architectures were the case. So there was right from the beginning the idea that there is need to bring the telemetry data from the machines as part of the platform without too long latency. Now, but this slide was then about the AI-ready data platform characteristics, and next we go to the manufacturing characteristics. So why is manufacturing different from any other domain, and what's so special about it? This relates to 3 differentiators, and the first one is asset framework. So as known, the manufacturing corporations are asset heavy. They own expensive machines, and how these machines are forming the asset hierarchy is a very important factor. So in order to use the data, this asset framework or asset management needs to be in place concerning the own production sites, but also concerning those products, those intelligent products, for example, harvesting machines that go out to the world. So there needs to be some sort of linkage to the installed base of the own machines. The second one is the engineering technologies. So when the products are designed in manufacturing corporations, there are the engineering data, product lifecycle management data, pictures, images, documents, so on. And this data is also a characteristics of manufacturing that does not exist very much on many other domains. And then maybe the most important one is the local production sites, so the operational technology, and as mentioned, the physical distance has been keeping these locations separate for quite a long time, but now we're living an era where the technology has developed enough for combining these as part of the data platforms on a consistent manner. Here on Outokumpu side, this is about there is more interest towards the contextualized data product, so defining what comes out as data product and then utilizing the platform, which we are talking about a bit later on more. And on Ponsse side, the connected edge has played an important role with the collaboration of us and Ponsse concerning what edge capabilities are needed on the production side in order to bring the data as part of the platform. This picture is then illustrating I would say the main difference between the data platform, any data platform, and manufacturing data platform. So on any generic data platform, the data sources come from IT. They are IT systems that are kind of designed protocol-wise and by nature to take part on the data platform. And then on the right side, there is the manufacturing data platform. And as you can see on data ingestion side as data sources, it's not anymore only IT, but it's also OT and ET. And these are not only similarly looking acronyms, but for example, the OT systems have very different protocols and very different ways to operate, as mentioned earlier, due to the division of IT and OT world. Yes, that was it about the definition of the AI-ready data platform for manufacturing, and let's now take the look on the architectural evolution. So it hasn't been always this way, but it's a kind of a result of a longer period of time. So Kalle, how would you see the path from moving the earlier phases to the current architectures?
Yeah, we've been working on quite a few manufacturing data systems, and I see there being an evolution, which is quite natural there. But how I see it being is that we've been always very good at having set of functions to deal with the operational data, and that has always been there since the IT has been or OT has been in there. But from there, I see that the systems have developed towards centralized data platforms. And this is where most of our customers are currently standing. They've got centralized data platforms set. And then we've also got quite a few cases where we see developments towards AI-ready data platforms. And when we've seen those developments, we've also seen experiments on doing cross-enterprise intelligence on top of those AI-ready data platforms. When we dive a little bit deeper into the evolution, we will start with site-specific operational databases, that being historians. Historians are the backbone of the operations, but we shouldn't use them as a data lake for AI, as they lack the context for business context, which is not, it doesn't work for AI. And also integrating historians is a nightmare, definitely a nightmare. So what we would recommend there is not to take out the historians of the play, but have them there and recognize that they are an important source for the data platform, and we need to bridge that. When we do that, we are starting to talk about centralized data platforms. Centralized data platforms are optimized for harmonizing the KPIs, having standard reporting on top of it, cross-platform or like cross-enterprise access to the platform. The problem is still there that the context is not in place because they were not designed for having structures and context in place as far as we would need them to be for AI-ready data platforms. And that's why OT data quite often remains siloed, and the contextualization is not there to an extent that we would need it to be for AI-ready data platform. So it's definitely a good progress, but it's not AI-ready. What is AI-ready data platform then? It's a contextualized, structured, and governed data platform. It's a layer on top of our IT, ET, and OT sources. And the shift being there is the repeatability. So we've got all the data in place. We've got ERP data, MES data, we've got OT data there. They are on par with each other so that we can start working on that and generate analysis reports, use AI on top of it so that it's unified data and we can spread it across the organization. What we can do there then is we can build operational excellence. We can optimize our operations globally within our enterprise. We can empower our workforce, and we can build advanced automation and AI on top of it when we've got these measures in place. How we do that is by utilizing our standard architecture for data platforms and having the manufacturing specialties built into it. So what we've got here in the middle is our technical capabilities, getting the source data through our data pipelines all the way to the information layer where we can then publish it to our workforce. That is the foundation for our AI-ready data platform. What makes that technical capability into AI-ready data platform is that we've got the governance in place and we've got the operations in place. So we know that it's well governed, it's well operationalized, so that we know that every time we look at the data, it's in good shape.
Okay, I think now we are up to date with the different twists and turns of the architectural evolution. So maybe it would now be a suitable time to go a little bit deeper to the structure of these modern data platform. Kalle, what is it composed of? What does it consist of, and what kind of solutions are there as a blueprint for this AI-ready data platform for manufacturing?
So as we saw from our architectural diagram, the technology needs to be there. And the technology needs to be adjusted to manufacturing context so that we will have all the data ingested into the data platform in a unified form. So we're talking about OPC UA interfaces, MES, PLC, SCADA interfaces. We're talking about ERP data. We're talking about PLM data, as you mentioned earlier on as well. And that data needs to be unified so that we can utilize all the data. And also we will have systems with larger batch ingestion needs. So that needs to be built in as well, but so that it's all unified. so that we will have all the data available. What we should have there for that is local and cloud compute, because we will have the local needs, so sites being local, but we will also have the workloads that are heavier than needs to be in the cloud. We also need a place to have our models stored so that we can distribute it to our local sites. So having this sort of hybrid architecture is important there for operational and analytical needs, but also we shouldn't be building hybrid architectures for the sake of doing them. We should build them for a need. When we've got those technical capabilities in place, we need to be sure that the data is readable and we can use it, or our users, to be exact, can use it. So we should be utilizing information models such as like ISA 95 based or ISA in general based equipment hierarchies, so that we will have a natural hierarchy for our data that, for example, our site consists of different factories and they are naturally close to each other and the relations are in place. Why we need that is that we want to communicate the data, we want to have the context and semantics in there. So AI and humans, they love structured and contextualized data because that's the only way that they can make sense of that data. Also, what we need is to have the quality of the data well established, or the measures to do it, to having the quality in place, so that we know that when we are using the data, when we know what data we are using, we know that the quality is in good shape. So this is actually how the raw factory data becomes reusable for AI. Having standard models, giving them structure, semantics to give them meaning, and embedded quality checks to make them trustworthy. When we got the data, we've got the data flowing, we've got the meaning for the data, we've got the context built in, we've got the quality in place. We have an asset, so the data becomes an asset. What we want to have is a good ownership and decision models who can use the data, being the governance of the data, and also the security measures, so that we know that the data we've got doesn't go away from our premises. We know who can use the data. We know that the data stays in shape. So in manufacturing, governance is not actually it's not a bureaucracy, or the security shouldn't be seen as a blocker. I think that is actually what makes the data system scalable. When we go to the direction of an AI-ready data platform, we can see that the data is in place, we can trust it, it's secured, governed. That's the time when we would start to use the data. So we want to empower our workforce with the data, the usage of the data. So we want our users to have measures how to do it. So they should have the catalogs in place, lineages in place, that they can find the data. They should have the right tools that they can use the data with the right tooling. And also they should have AI assistants in play so that they can even make it faster and easier to use the data. So that is the core of AI-ready data platform, being able to utilize the data, being able to use it for your own work and for your company's needs.
Okay, then next we are then diving a little bit deeper on the case examples. So now we have heard quite a bit about the structure and content and blueprint of the AI-ready data platform for manufacturing. And as we have every now and then referred to the two mentioned case examples and references of us, just to mention that these two are handpicked from a longer list, so we have a larger amount of activities with many of you, and here for particular reasons are selected the Outokumpu and Ponsse. And when we first go a little bit more to the Outokumpu side, so this is actually a reference of actually two references that are kind of complementing each other. So the first one is the global data platform, so we are talking about the technical capability, and the second one is the digital innovation hub, so we are talking more about the organizational structure and mechanism as a capability. As mentioned, Outokumpu is the sustainable steel producer, world's leading one when it comes to the sustainable stainless steel, operating in almost 30 countries, and collaboration between us has been ongoing for quite some time. When we go a bit deeper to the global data platform side, just to mention that the text is small, and we are not aiming to cover all of this here, but the materials are in disposal later on. But just to mention here that the need for global data platform was quite clear here. So there was need for a place where to gather globally all the data, and where to which would then feed the ML platform, ML AI related tools, and aiming for process optimization, quality improvements, reusable machine learning AI solutions across all the production sites and across the whole corporation. And the result, when the global data platform journey was done from the beginning to the end, the results brought not only tech capabilities but also cost efficiency and common ways of working, which are equally important when we are building capabilities for data solutions. But as mentioned, the global data platform is more like capability or technical competence, and then digital innovation hub is kind of the other side of the coin here. So in collaboration between us and Outokumpu, there was also seen the need for harvesting and screening the initiatives for how to use then the global data platform, and what kind of ML AI solutions there would be need for. And here it is also not only the structure and organization, but also governance, way to operate, and how to make it run efficiently. And when the digital innovation hub journey was done, the result was then company-wide systematic approach for identifying, proving, building, and eventually also scaling up different digital innovations that would then be utilizing the global data platform.
Sure. Then we would like to talk about Ponsse. Ponsse is the Finnish forest machinery manufacturer, and I think Ponsse is a strong example of data-driven manufacturing. The challenge Ponsse had was that their data was fragmented across machinery, manufacturing, services, and customers. That became a problem with a limited visibility. So the data was scattered all across, and the data was there, but we couldn't see the whole picture there. And that affected so that we couldn't scale the data-driven services there. So what we did together with Ponsse, we built a foundation for data platform towards AI data platform, AI-ready data platform, so that we built the basis for the data platform into the cloud. We added integrations and APIs on top of it, added edge computing into the play, and also generated them or developed them a modern MES that was in the core of their production. So together with these, Ponsse could connect the fleet, factory, services, and customers' data into one data platform. And it was unified, it was structured, contextualized, which then led into better reporting, forecasting, and operational visibility. And the takeaway here is that when all the data is brought into the data platform, the measures are taken into account, what comes to structuring, what comes to contextualizing, governing, operationalizing the data platform. We can build operational improvement and new digital services on top of a AI-ready data platform. Yeah, so now we've taken a look into what AI-ready data platforms are in manufacturing. Should we then start to talk about how to create one?
Yes, let's do.
What I see as key takeaways about what we've been talking about here is that we should be bringing down our data silos so that all the data is available. We should be also using proven patterns with standard informational models, hierarchies, so that we know what data belongs to where. Then when we add good governance on top of that, that becomes trustworthy, and we know that the data will be there also tomorrow. And when the structures and models are in place, we know that the data is AI ready and thus it's future proof. What about then the steps towards?
Yes, I would like to point out 3 different steps how to go forward and how to really start developing the AI-ready data platform for manufacturing purpose. And the first one is the classical need of prioritization. So it is, I think everybody knows this need and the importance of this step, but still it needs to be emphasized more because it's just too easy to slip or drift a little bit away from the actual need. And when the real need is lacking, it's not only the lack of motivation after the first enthusiasm, but it's also the lack of funding. So it is probable not to get enough funding if there is no real need behind, not for only technical exploration. Then the middle one is the leverage of the right tools and partners. So it makes sense to carefully select the suitable partners for this route to share this journey. And of course it can often mean us, but it's not always us. But I would also encourage to not to go fish beyond the sea, but taking a look on the internal resources, because corporations are often big, and the first thing to do from if you are representing a business is normally to open up your needs a little bit towards the IT side. So just to make sure if there are some structures and capabilities in place, and that would be the way to ensure the architectural fit, so that it does not it will be also supported in the future, and it would be well aligned to all the existing tools and systems. And sometimes it might be the case that there are many of the needed building blocks already in place. You're just not yet aware of those because the corporations are, as mentioned, very big. Then the third point here is start small, scale fast. So it is often too heavy to just build capabilities, no matter how important capabilities they are. So I would encourage to get started with a use case or a handful or set of use cases, and and proceeding towards the minimum viable products quite fast, and then expand incrementally, because it's always possible to build the capabilities along the way, and that's the way to ensure that the capabilities are built for the real use and real use case, and not only for the sake of technological exploration or technology enthusiasm. Yes. Then a couple of words how we are able to help according to each project phase. So often it helps kind of structurizing the different solutions in your head. So first starting with the assessment or design phase, then proceeding to the proof of concept phase, then to the fully blown implementation, and eventually the LCS, lifecycle services or operations phase. And sometimes, of course, it makes sense to agree and contract all of these at once, but sometimes it's more safe and easier to get started if focusing first on the assessment and design phase, or combination of assessment, design and proof of concept phase. And we can help in each one of these phases, and also maybe emphasizing the fact that there is no need for vendor lock-in, so it's about you to pick and choose where you need help, and then also balancing between the in-house capabilities and the help of us. As many of you might know, we are also technology agnostic, so capable in operating with every relevant technologies, and working and collaborating with the relevant big vendors, so including also data platform providers, but also AI related tools. And worth mentioning that Solita has built an own function AI, Gen AI tools as well, so we are also kind of experienced on internally inside our own company.
Sure. Based on what we've just heard, would you see that Solita as a Nordic data powerhouse would know how to combine different data sources, build opportunities on top of it, no matter if it's IT or OT data? What do you think?
Yes, I would not only think, but also having seen that this happens in reality.
Well said.
We are soon about to reach the end of our crash course about the AI-ready data platforms for manufacturing, but I would like to point out two upcoming Solita contents that are only a couple of weeks away. And the first one would be deep dive to semantic layers. So this is not a crash course, this is a deep dive, so we are focusing on a little bit more narrow scope, but going deeper to there. And then you will hear more about semantic layers, which are kind of building the explanations on top of the technology. So how to help the tech-oriented data to reach a little bit more towards the meanings, human beings, and also the AI solutions. And this is going to happen on 16th of April. Then the next crash course topic is transformation beyond projects and technology, and here the content is covering different aspects of the transformation cases, and the fact that it's not only about technology but also the humans, transformations, structures, organizations, and so on.
With that, I would like to thank our listeners taking the time for listening our crash course on AI-ready data platforms. And now it would be time to go through our questions that have been posted over the talk.
Yes.
So
hopefully we have some.
Yes, we do. So, first one being, what kind of AI do you think that AI-ready data platform should support?
Yes, I would first start that this question is, I would address this with a little bit more generic approach. So the landscape is evolving very fast, and there is a lot of different solutions, and we know that it will evolve very fast also for the upcoming years. So I wouldn't emphasize any particular technology or tool set, but focusing more on connectors. So making sure that the necessary protocols, necessary integration methods, integration platforms, and so on are in place, so that it's easy to adapt to whichever use it might concern. But how would you say about that?
Yeah, I agree, and I see that there's still a lot of room for optimization in industrial processes, and I think the traditional machine learning way of approaching it is working very well on those, and I think there's still room for those. What I see being there in the future as well is the Gen AI work paths, or how Gen AI orchestrates the ML workloads so that it's more automated and timely when the AI is used in processes. So that would be my 2 cents on top of that, what you just said.
Thanks, and I would describe it much more than 2 cents, maybe hugely more. Any other questions?
Thanks. What kind of automation context Solita has? So what are our partners in that field?
Yes, on automation side, Solita has been doing several different kind of edge related systems, and working much on how to receive the data and information from, for example, OPC UA or Modbus interfaces, and then processing, aggregating data on the edge level. But in this case, I would maybe refer more to the protocols and the edge capabilities, but not mentioning any particular automation partner at this point. Maybe we have something upcoming and something to be revealed later on concerning names, but I would emphasize the fact that the protocols are there, they are quite standardized, so building the edge solutions and automation related solutions according to the logo list that we just showed is kind of well sufficient in order to build very efficient edge solutions.
Yeah, and also to add to that, I think that we talk about this bottom-up, top-down approaches. So what we've been quite a lot utilizing in our projects is hyperscalers capabilities in that field. So there are a lot of built-in capabilities on their platforms as well. So they are definitely worth taking a look into.
Exactly. I think all the hyperscalers are proceeding and providing the infra towards the edge technologies and towards the automation and process technologies very important. So I think maybe every month something new is happening concerning that, opening up new opportunities on top of the hyperscaler edge solutions.
Yes. Then about regulative requirements, how do you see the path being for manufacturing data to be compliant with the EU Data Act?
Yes, this is changing the field quite drastically. Referring to the CRA regulation, I think it is a very hot topic currently, and also Solita has been working on top of this one. So we need to make sure that there are new capabilities there, and we know more about the equipment and devices that we have on the field. And as we know, European regulation might also change. So it is kind of, well, maybe exploration is a wrong word, but it's not always sure that when European Union comes out with a regulation, there could be also some kind of changes afterwards. So we need to have the hand on the pulse concerning the new regulations of the devices and still being capable in adopting to many different circumstances and occasions.
Yeah, and I think the key aspect here is that when we've got a well-designed and composable architecture in place, we can control the regulations and adapt to new regulation very easily when the architecture is well designed. So that is the key for tackling the change in regulations.
Yes.
Yeah, then there's a question about different manufacturing data hubs. So, for example, being Hypervisor, UMH. So, how do they fit into the picture of AI-ready data platform for manufacturing?
Well, I think there is this is a matter of opinion, but I would see it necessary to have edge capability for the first place, serving as a gateway. So serving as a local endpoint that is capable in taking the data to the cloud and capable in doing on an easy manner the light processing of the data, aggregation, and so on. And I know that there is a very big amount of different edge solutions. So for some, it might be necessary to aim for very large amount of local capabilities that some of these mentioned systems provide, so that there are the kind of own visualizations and data processing, ML algorithms, and so on the local side. But I would still say that it makes sense to get started. Not being painted to the corner, but getting started with the gateway and aggregation features and capabilities, because then it's easy to get some tangible results and then making sure that it's possible to proceed later on to the more advanced local solutions.
Yeah, what I see being a benefit of this kind of data systems is that they reside close to the local processing, close to the local compute, even PLCs that are generating the data from the sensors. And when we want to contextualize the data, we want to start it from early stages when the data arrive to the data platform. So when we use this sort of approach, we can add the context immediately into the data. And when we are going higher up into the higher layers, we will have the context there and we can utilize the data immediately there. So I think that is the beauty of these lower layers with the added functionality that has become into the field recently.
Yeah, I think that's a very important point, because then if the context is lost, if the context is available there in the automation system, but it's lost in the transition, it is a very big burden to manually once again add that context later on, for example, in the cloud, in the data platform. So whenever possible, it makes sense to just stick with the existing context and making sure that it's brought all the way up to the data platform.
Yeah. There are two questions that I'd like to tie together. So there's a question about how can it be guaranteed that LLMs processing data with LLMs doesn't distort the numerical data? And also, besides Gen AI, how do you see agentic AI in manufacturing environment? I kind of see that these questions are answering each other in a way that, as we mentioned earlier on, I think AI is important in manufacturing, and we should have the Gen AI added into our architectures in that way that we have the Gen AI orchestrating and answering questions so that it doesn't necessarily touch the data, but instead it orchestrates it and provides the data as is. So if we've got some functions that are translating the data directly, Gen AI wouldn't be necessarily touching the data, but telling that this data is available here and it should be brought to over there. So it kind of helps with processes, not the data itself. How do you see it?
Yes, I think so, and I think already now many LLM Gen AI tools are providing also the link to the initial material, so that it's not if we are hesitating, we can check ourselves where does it come from, and I think this sort of mechanism needs to be brought very carefully also to the manufacturing solutions. So we need to make sure that there is no space for hallucination, and whenever somebody wants to check what's the origin of the data, it gives kind of link and relation to where does it come from. Also, when we are talking about the conclusions that are drawn by AI tools, it is necessary to flag the fact that okay, this conclusion is done by AI. So I would see it so that there is, particularly now when we are still in rather early phase with all of these new tools, the fact that there is always human between, so it can make the operations much more efficient while still having human being making the necessary kind of checks before taking the actual use and also taking the responsibility on the results. And I would see that we are proceeding towards more and more automatized solutions through these sort of phases.
Yeah, I agree. So kind of how I want to see agentic AI being part of the process is that there's a human in the loop. Agents are there. Their processes are complicated, so we need agentic workflows there on the platforms. But what I want to see there as well is the human in the loop, because that is something that someone needs to take the responsibility.
Yes.
Sure. There's a question about the cases that we presented. What is the timeline for those cases, for those Outokumpu and Ponsse cases? So what was the rough timeline for them, and what were the resources that we required from, or what was the requirements for the resources from the company side in those cases?
Yes, I think these are more, both two are rather important questions, and I wouldn't go too detailed on these particular cases, but concerning the timeline, I have to say that I'm still amazed that the data work doesn't seem to end. So it's always possible to do a sharp, well-scoped solution, but maybe some 5 years ago, I thought that if it's successful, then it's done, and then we don't need data work anymore. But now, having seen quite many times that if it's successful, well, nälkä kasvaa syödessä, so while you eat, you get more hungry. So when you see that, okay, this is possible, so it just keep on going and keep on developing. But in these cases, I would say that building a data platform as here, I think starting from half a year or 1 year and scoping well, making sure that the use cases are on the table and we are first focusing on the right topmost things, it would make sense. And concerning the other question, I think it was about the in-house resources, like what is needed from you when starting the collaboration. I would say here that it is necessary to have the champions or commitment in the house. So that's the first starting point. So it cannot be these kind of things cannot be outsourced on a mental level. So we can help on many aspects, but there needs to be somebody who is genuinely interested about the results, and hopefully several these sort of people. So this is the first starting point. But then what else is required? We are not talking about us as one supplier, but quite often there are systems, there are system integrators, and there are different companies that are handling these systems. So I would say that ensure ensuring the availability of the needed data well in advance is very important thing to do, because otherwise if we have agreed on a project, everything seems clear, it might get blocked by not having the necessary data available. How about you? Any additions?
I think you put it very well, but I think when you said that it's kind of an ongoing process, I agree, and there are new requirements, and I think what it tells about is that we and our customers who we are building these are seeing the benefits of the data work and data systems that we are building. So that is the kind of nicest part of our work, to see them in action. And also how I think of this is that the resources are important because the best ideas come from our users.
Yes, I think that is well put.
Sure. Then next one would be, could you give some tips on how to get started with information models and modeling the business aligned layer to interoperable data layer?
Yes, I would see that it's maybe the first advice would not to build an Isaac's church. I don't know if that metaphor works in English, but anyways, do not build a Sagrada Familia out of this data model, but just starting small, starting for the purpose, and then letting it expand bit by bit, because otherwise it might, as mentioned earlier during the presentation, it might be that the motivation and funding are both used, and then the big data model is not ready yet. So I would emphasize the fact of being need-based and building the data model for particular use cases and then expanding it from there.
Yeah, I think what is important is that there are standards for data models and information models that should be followed, but also it's important to modify them for your use so that it fits your company language, it fits your use cases, as long as they're consistent across the companies. So that is important. And as you said it, building it piece by piece, starting from the most important parts. So
I think that's a very, very good approach, because I think every one of us tends to think that our case is unique. So our manufacturing process is unique. And of course, at one extent they are, but still tapping into the existing models makes a lot of sense, because then you don't need to start with the empty paper, but you can see how it looks like and then modify it based on your own needs. Very good point.
Yeah. Then there's a question about how we utilize AI. So are we utilizing AI to build data platforms, or are we utilizing AI for analyzing data on existing platforms? And on top of that, is there human involvement still required in the process, or is it mainly software engineers or technical professionals who are involved in these workflows?
I think at least combination of these. So there are many ways of using the AI internally as part of the project work. Maybe also worth mentioning that whenever we utilize AI as part of the projects, it has been commonly agreed with you. So we are not leaning too much forward with the tools, but there is definitely need for human involvement, not only for communication but also when developing the solutions. So I think this is kind of developing on both ends, and to making the most out of the modern AI tools requires capable human beings who are using them also internally, but also as the end user solutions. So I wouldn't rush into too independent solutions yet so far. Yes, what were the other questions, and would you, Kalle, have something to them?
Yeah, I think both use cases are valid. So We can use AI to build data platforms. We can use AI to analyze or use data in other ways on top of existing platforms. They are both valid use cases. The important part I see here being is that there should be a process. There should be a process that is similar for all the use cases. It doesn't need to be that the human is involved, but if the use case requires human involvement, that should be in place, and that would be the most use cases. But the process, when it's in place, we know what to expect from the process and what are the different steps in the process, and we know that can we trust the results of the process or not.
Yes.
Yeah, so with that, I think it's time to wrap up. So any last words?
Well, at least I'm glad that there were so many of you listening to us, and also at least I would like to consider it a success that we received such a big amount of good questions. So thanks on my behalf. Very interesting session.
Yeah. As well, from my behalf, thank you very much for attending the session, and the questions were very good, and actually they inspired me a lot.
Same here, and hopefully we will have the chance to continue the discussions here. So don't hesitate to also send us some further questions or initiatives, and we will welcome those happily.
Yeah. Thank you.
Thanks.